Hello and welcome back to my channel. The Microsoft Excel World Championship is underway. Just last weekend we have had our qualifier rounds. And so for today's video I'm going to start by showing you the morning session of the qualifying round, which is the session that I participated in. And then hopefully in a later video you can see the afternoon session of the qualifying round. The qualifying round is a little bit different than most of the cases we see. Let me just read the story here for you. John Smith is a big fan of the Financial Modeling World Cup and Excel esports tournaments. He took part in all our previous MEWC championships and all the battles on the Road to Las Vegas series. Each year, since we launched the Excel esports format in 2021, John has been able to solve every single case except one. Now he needs your help to solve these remaining cases. One case from each of the years 2021 to 2025. Help John by getting the right answers to each of the questions below. So the key difference between this case and the other cases we've seen, well, there's two key differences. Number one is that the levels in these cases, they're not really levels, they're described as sections. And each section is based off of a previous case. So we see here section 1 is based off of the case, the card game from 2021 FMWC Open. Section number 2 is based off of World of Warcraft from last year's finals. Section 3 is based off of the case Maze from the 2022 Microsoft Excel World Championship. Section 4 is based off of Collecting Scarves from this year's Road to Las Vegas series. And then Section 5 is based off of Vlookie the Gold Miner for the 2023 Microsoft Excel World Championship. So all 5 sections are unrelated. You can solve them in any order, one at a time. There are also 5 bonuses, and the 5 bonuses here are related to each of the sections respectively. So let's go ahead and give this case a shot. See if I can solve this case now in under 1 hour. Feel free to watch along with me, play along with me. Feel free to pause the video if you want to take a closer look at my formulas. But let's give this a shot. Here we go. Alright, so in section 1, we've got the card game. 2 players are playing a card game. Each player is dealt 10 cards. Cards numbers 1, 3, 5, etc. go to player 1. Cards number 2, 4, 6, etc. go to player 2. Then the players calculate the points based on the rules below. The player who has the most points in the winners. Here's the scoring. Number 1, each card is worth a certain number of base points following this table here. Step 2, the base points are doubled for the cards belonging to the trump suit. And step 3, if a player has 4, 5, 6, 7, 8, or 9 cards of the same suit, the points for each of these cards are multiplied by that number respectively. Alright, so there's a lot going on here. Let me go ahead and move this onto its own sheet. So I'm going to call this S1 for section 1. And let's go ahead and paste this information in there. Give me the current score. I don't need to see that. All right. Now, the beautiful thing about this case is that they gave us this lovely table, which we are going to steal. Because that table is a nice little structure that we can use to calculate the points for each of the players. Right, so let's go ahead and get our data table runner in. Oops. Delete all these, and then let me just add this blank to take out that number 0. Excellent. All right. So here's what we got. We got player 1 cards, base points, trump multiplier, same suit multiplier, and points. Now, the odd number cards go to player 1. The even number cards go to player 2. So an easy way to do that, we're going to use this wrap rows. And what this does is I'm going to show you up here. I'm going to take this one-dimensional array, or as Excel calls it, a vector. I'm going to wrap it to 2 items per row. So you see 1, 2, 3, 4, 5, 6. Exactly like the instructions tell us. Now let me go ahead and change that to these cards down there. So now we have which cards go to player 1, which cards go to player 2. So I'm going to go ahead and put this in this table here. So this will be 2 a row. Those are the cards there. And let's see, base points. So the base points are, I'm going to take the card number. So I'm going to take the left of these. For that many characters, I'm going to XLOOKUP that in this table here. that should give me the base points for each card. Now you see I'm getting some errors. The reason I'm getting some of these errors is because when I use the left function, it puts out the results as a text instead of as a number. And so Excel doesn't see them as equals, it's not matching up. So what I'm going to do is I'm going to put this in an if-else statement. If it doesn't work with a text, try it with a number. To turn this into a number, I'm just going to add ×1 at the end there. So now everything is looking up. All right, trump multiplier. Let's get the suit out first. So the suit is just by taking the right. All right, so we got a lot of hearts here. What I'm going to do is basically take that equals this here. So we got true and false. Now, if it is true, we get a multiplier of 2. If it is false, we get a multiplier of 1. So I'm just going to simply add 1 to this. So now we have 2s or 1s depending on what the multiplier is. Now, same suit multiplier. Yeah, I think what would be very useful here, I probably should have done this before. Just pull out the suit. There we go. Now for the same suit multiplier, why is it going out here? That's interesting. Is there any reason why it's doing that? I actually don't know. Oh, that's why it's doing that. Because for some reason I have this going down to that row. There we go. Okay. Now for the suit, okay, we got the suit. Now same suit multiplier. So count those. Alright, so we got 9s and 1s. And now what I'm thinking of is if this is less than, what was the number, 4, then we actually want to turn it to 1 because that means there's no multiplier. So if that is less than 4, 1, otherwise return that. Now we won't be able to see it here, but when we copy it down to this table, then it should work. In fact, let me go ahead and add this extra suits row that I did before. There we go. And actually this should be from player 2. All right, 2 row. We got to put it in a single row. There we go. Okay, same suit multiplier we got. Okay, so then the points we can just basically take this times that row times that row. How do I get negatives? I put a negative sign. Where did that negative sign come in? I don't know. We put the total in there, 2,581, which I think is the answer because that's the higher score. Good. Let's go ahead and take this, put it in the second table. So this player's got a score of 521. And basically all we need to do is take the max of those 2 numbers. Good. All right, let's get our data table going. Over to the case sheet. Do they all match up? Yes, they do. Excellent. All right. Going on to section 2. World of Warcraft is one of the biggest massive multiplayer online games out there. In WoW, the goal is to level up your character through quests and dungeons. As you level up, your characters gain new skills, unlock different spells, can grind gold to buy golden resources, and can also learn professions. Last year's final game of the Microsoft Excel World Championship was World of Warcraft themed. We got this idea of levels. In WoW, players start their journey experience level 1 with 0 experience points. They need to gather 500 points to go from experience level 1 to experience level 2. Then each subsequent experience level requires 10% more XP. It requires an additional 550 XP to go from experience level 2 to 3, 605 from 3 to 4, 665 from 5, from 4 to 5, etc. Do not round these points at any time. Hint, solve bonus question B before solving the rest of this section. Alright, well let's go ahead and take a look at bonus question B. How many XP points does a player need to reach level 50? Round your answer up to the nearest integer. Alright, so let's go ahead. We'll call this section 2. And are we only going to have to go to 50? What does actually level 2 require? How many XP points will each player have upon reaching level 50? Okay, so we don't need to go beyond level 50. So what I'm going to do is we need to start with 1. I'm going to have 51 rows starting with 0. And is it level 0 or is it level 1? Oh, it's... They start with experience with level 1 at 0 points. Okay, so we can just change that to 50 starting at 1. 1 is going to be 0 points, and they said 2 is 500. Yes. And then each one you add 10%. Alright, so there we go. And then, so that's how many experience points added to get to the next level, right? And so to get the total number of experience points you need at each level, we can do that there. Right, so level 2 requires 500, level 3 requires 1050, level 50 requires that many points. So let's go ahead and answer bonus 2. Round up to the nearest integer. Okay, so round this up to 0 digits. We go 528,595. Okay, so we got the bonus. Let's go back to the section. Right, so we're going to do this by doing quests. By the time we start calculations, our player have already spent some time in the game. Their goal now is to increase their player level up to level 50. They will do so by doing quests. Completing the first quest will instantly increase their XP by 4,500 points, the second quest by 4,600, the third by 4,700, etc. Each next quest will bring 100 XP more than the previous. Okay, so how many quests do they need to do? I actually don't know. So we're starting with these numbers here. So let me go ahead. Let me just create a nice table here. Bring these numbers over. Why did I add an extra period there? And I'm going to do that again. Okay. There we go. I'm going to highlight this in yellow, telling me that that is just a blank cell. This is my example. I've got that. All right, now the cases, they say the first case is 4,500. Let's go 100 quests. So we'll do sequence 100, starting at 4,500 and adding 100 each time. And then we'll see how many XP we've gained total after doing that number of quests. Now, if I take that and add those numbers there, okay. So this is all making sense. Now I just basically need to see when do I pass that number. 528,594. Okay, we do pass it. So, if I look up this value, actually, let me round it up. Actually, no, it did say do not round, so I'm just going to look up that value into this array here. Return from that same array, but return the next larger item, because we need to see how many points when we go beyond that, right? Oh, good, we do match. All right, so if I copy this and bring it to all of these other ones here, we don't do the yellow because that's just a blank. Oh, those are not adding. Oh, because I didn't lock this in. Okay, this part needs to be locked. All right, let's try that again. Okay, good. We're getting different numbers this time. That one's coming up to an NA. Why is that coming up to an NA? Are we just not matching? Oh. Oh! I forgot to lock that too. Come on, Ben. Let's lock this. There we go. Okay, I think those are our answers. So let's go to call, bring these numbers over. Excellent. Cool. All right. Section 3. A mad scientist is training mice to learn to solve a maze. The maze is a 10 by 10 grid. A wall is indicated by a shaded cell, which is gray. Water is indicated by a shaded cell, which is blue. So let's go and take a look at the map for Section 3. Oh, beautiful. All right. Oh, and they have different grid numbers on these two. Not a big fan of that, but we can go with it. The mice can only move vertically or horizontally, not diagonally. The movements of the mice are provided with the letters U, D, L, R. Okay, I see that. In case the random move asks the mouse to move to a space that is occupied by a wall, they will not move and stay in the same position. In case the random move asks the mouse to move to a space that is occupied by water, the mouse will get scared by the water and instead move in the opposite direction. If that cell is also occupied by a water or wall, then the mouse doesn't move and stays in the same position. Okay. Task, where would each mouse end up after 30 random moves? Okay, so let's go ahead and bring this in. Let's start a new sheet. Run through another data table. Level 3, section 3, whatever it's called. There we go. Boom, bring that in. And this goes all the way out to column AL. Okay. I'm gonna add that blank in there as well. Okay, so there we go. All right. Now, I want to flatten this map, but it's going to be a little bit tricky because this grid is not following the original grid. And I'm going to bet that these questions are following the grid that's laid out on the map. So that's going to just add a little bit, but I think we can do it. All right, let's give it a try. Roll call, address value. Okay, so first thing, let's call this section 3MP. And then let's see if I can change the colors to words. So gray is going to be a wall. Okay, it's not going to let me. Okay, I think this is a problem with my OBS, because when I'm running OBS, my resources aren't really the best. I think Excel normally can do that. Alright. Did that work? Oh! Okay, wait a second. Huh, interesting. It's not really... I didn't want to name that as a range, but you know what? That could actually work. Alright, and this one is going to be called water. Alright, so... okay. So, let's see here. I need to put that in a 2 call. I'll do that here in a minute. Let's go ahead and put that in a 2 call. Now, the thing is, I need this to start with 0, because that should actually be 0, because A1 is right here, right? So I'm going to take that and subtract 4. I'm going to do something similar to the column. So 2 column map. Now column, that's going to be 0. So we're going to subtract 3, not 1. Now the address is not going to work. That is not going to work. But I need it. Okay, yes, I need it because the starting cell they give us is an address. So let's do address. And then that's going to give me some errors. So let's do if error. Let's just leave it blank for now. Let's see if we need it later. And then value is just 2 call that map there. Okay, so there I've got my flattened map out. So let's go ahead and try this. So let's say move, start row, start call. Okay, so move. How many moves? 30 moves. So let's do 30. So we start. This one's going to start there. So row. Actually, what I could do. That will give me the row number. I can't do, well, no, I can't do the same with column. That's a little bit trickier. So start column is 3. Okay. So let's try attempted move. Let's go ahead and bring this all the way down there. Okay, so let's see. D row, D call. All right, so then, so let's start with the row first. So if it's down, it's 1. If it's up, it's negative row 1. So minus is number search. So what I'm doing here is basically these are both going to return true or false. This is going to be false, false. 0 minus 0 is going to be 0. But if the letter was D, then it would say true minus false, 1 minus 0. That would give me 1. Right? Same thing with you. And actually, I think I could take these as ranges. Can that work? That can work. So you see for up, it's -1. For down, it's just 1. I can use that same exact formula. And so column, right is 1, left is -1. Beautiful. All right, so new row, new. All right, so let's say, yeah, new row, new call. So we need to do this twice. We need to see what's in front of us and we need to see what's behind us. Right, so new row or new call is going to be that plus that. I can't do it as ranges. That's fine. All right. New val. So what I'm going to do is I'm going to take it like that. Look up the array here. So let's do this and this and return what's in here. And just in case it comes up blank, we'll add that in there. Okay, so we have water. So let me just check. 10-4 should be D10, which is filled with water. Good. All right. So then, if that's filled with water, we need to check behind. So behind row, behind call. And I believe if I just take this and subtract this D row and D call, then that should get that. And then I can do the same thing, except I need to lock those columns in. I need to lock those 3. Okay. Behind Val. So we have a wall behind us. So, final, or let's say destination. So, if this equals water, because that's when it's going to change, right? If that is water, okay. If that is water, if this is not blank, then we just go to the original starting row and column. Actually, yes. Otherwise, we go to this row and column. Right. If it is blank, we go to that spot. Okay, good. If it is not water, if this is... I'm not done yet, fat fingers. If this is wall, then we're going to stay there. Otherwise, if it's neither wall or water, we're going to go here. I do believe that's what we are looking for. So dest row, dest column, dest address. And I can do the same thing there, except so PQ, this should be R. C10. Right, so we stay in C10. Okay, good. Now, if I do that, and if I fill all of these down, we can't fill these down. Oops. There we go. Okay, then we go to C9. Okay, that's all looking good. That's all looking good. So let's go ahead and fill. That's not going to work yet. That's fine. Whoops. Whoa, okay. Okay, can't do that. Just fill all that down. All right, and then we find ourselves an E10 at the end. Okay, that's good. That's good. That's good. That's good. Okay, so let's go ahead. Put that as E10. Let's bring all these numbers here. Run the data table. Okay. And then we can always check with the hints. So the hints are in game 41. The answer is in row 3. Yes. 42. The answer is in row 8. Yes. 43. The answer is in row 10. Excellent. Good. All right. Let's go ahead in section 4 from Collecting Scarves. You are a big football fan, as in European terms, and want to collect as many scarves of football teams as possible. In order to get those scarves, you must travel to those cities and buy them. All 100 unique scarves are displayed in the S4 Scarves tab, so here we go. Excellent. The data includes the city where you can get them, the city's coordinates, and the 9 color elements that make up each scarf. If you want to buy a scarf, you must travel to the given city. There's the formula to travel to the given city. Task. You are given 20 scarves. Find in which city you can obtain the given scarf. Provide the city that is located closest to it as your answer. Okay, so let's see. So let's find these cities first. Actually, yeah, let's find these cities first. So combine scarf. And I'm going to go ahead and combine the scarves here. So I'm going to add a concat column. And then I can XLOOKUP that into that brand newly created concat column and return the city. Right, so that's where these scarves are located. But the question is not where the scarves are located, it's what is the closest city to these scarves. Right. So I'm going to use this, and let's put these here. And I need to find out what's the closest city. Okay, so right, target city Hamburg. Let's see, XY. Put that to a column. There we go. And let's go ahead and list all the other cities here. X, Y, dist. actually what I can do is I can just like that. All right, so that's giving me all the x coordinates, it's giving me all the y coordinates. Let me get that formula over here. So I'm just gonna put that, I don't know, there. Here, that'll work. It's only temporary, so that's gonna work. All right, so 100 times x minus the target x squared plus y minus the target y squared. And is that everything? I think that's everything. So that's going to give me distances. Our hamburger is giving me 0, which is correct. Nearest, actually I could put this up here. So nearest city is the one that's going to be just above 0. So I'm going to x look up 0.01 in that column, return this column, return the next larger item. So we get Braunschweig. I don't know if that's pronounced right. It is pronounced right. I don't know if it's pronounced right. It's the right answer. Run through the data table based on that city. And let's bring, oops, wait a second. We don't need Hamburg, we need this one. We need to start with Maribor. There we go. All right, they're all matching up, good. Delete, whoops. Delete that data table. Let's go on to section 5, and this is the hard one. So let me read the instructions and I'll take a pause. Vlookie is a little dwarf. He works in a mine for the whole day, collecting gems, gold, and other useful materials. In the evening, he returns home and trades the collected materials for coins. See prices in the table to the right. There we go. The mine is a square 39 by 39 cells. The map of the mine is presented on a separate tab as 5 mine. Nice. Big mine. In case your computer has issues reading the Unicode symbols, we have provided the same map on another tab in here. So we're using numbers instead of the symbols there. Numbers of the tab correspond to the table on the right. You are free to choose which tab to use in calculations. When Vlookie enters the mine on day 1, it contains all the materials as depicted. Every day he collects 10 materials, makes 10 turns, and trades them for coins in the evening. The next day when he returns to the mine, those materials do not respawn. Their cells are now empty. As the mine gets depleted, there will be turns with no minerals within 1 cell distance. When that happens, Vlookie will be evaluating the materials in 2 cell distances. Vlookie will keep expanding the distance as no minerals are found. The turn ends once Vlookie collects a mineral. Each day, Vlookie starts at one of the 4 entrances. Each turn, Vlookie evaluates all the minerals that are closest to him, vertically, horizontally, or diagonally. He chooses the most expensive mineral, extracts it, and finishes the turn on the cell occupied by that mineral. Then he evaluates again all the minerals that are closest to him, selects the most expensive one, and collects it by moving to that mineral's cell. In case of a tie, Vlookie selects a mineral that is located to the right with the largest number, then to the mineral that is located on the right. See this example. So we have a priority order here. But now what tricked me up on the actual case was this priority was only 3 by 3. So I was thinking to myself, oh, we won't need to expand this. Fun fact, we need to expand this. Task, how many coins will Vlookie collect each day? Remember that with the passing of days, there will be more empty cells in the mine. And we have this example here. Whew, all right, there's a lot to consider. I mean, this whole thing has already taken up more than a page. But let's go ahead and create a sheet for this. So this is section 5. Paste all of that in there. And then let's go ahead and get our data table runner going. All right. And then right after I do that, what I want to do is I'm going to flatten out this map. So let's go row, call, result, or no, address, result, and then I'm going to add value. So that's going to be how many coins each one has. Now, unlike the maze one that we saw earlier, this grid actually matches the Excel grid. So I'm not going to have to do any extra math to it, right? So I'm going to call this section 5 map. Why do I keep putting this in the wrong place? Section 5 map goes in here. There we go. All right. So we're going to call map, section 5 map, and get the row. Call section 5 map, get the column. I don't need to actually write the word get. My fingers are not cooperating. Oh, I forgot the word map. That's why. No, don't put it in there. Put it in front of this. There we go. Alright. The result is 2 = 65 map. And then the value is going to be x lookup this into... Let's see, we're doing symbols here. So we can go in that column, return this column. Okay. Let's just make sure that this worked out correctly. Oh, that's a lot. You know what? Let's just do it this way. So do we get any errors? Oh, we got errors. Why do we have errors? Let's see. We have NA errors. Oh. It's because those are returning as 0 instead of blank. So what if I just... I think I can do this. Now am I getting any errors? Yes. B21 and 21 U40. Let's just check these 3 cells. So was it B21, B20, okay, and 21, and you've, okay, so those are, okay, so those are just going to be 0. Let's just go ahead and put that in as 0. Now check if there are any errors. There aren't. Okay, we could go with that. Okay. Back here. Number of turns 5. Okay. Now, here's what I'm thinking. The first thing I'm thinking, normally when I go to another sheet, I want to do a data table. I can't do a data table because these are not independent scenarios. The key thing is, where was that one line? The minerals do not respond. So all of these are still going to be connected. I can't just run through a simple data table to find the answer. So it's going to be a little bit tricky moving from the example to the actual case, but I'm going to try my best. Now, let me just see here. Actually, yeah. Let's see. Day, turn. So this is going to be day 0 there. Let's do start. We're going to start here. Actually, let me add an extra row just in case I need it. Now, I want to build a formula that I can adjust easily depending on how far we need to go. So here's what I'm going to do. I'm going to create one step column here. Now, I'm not normally a guy that likes to use single cell formulas, but I think that's probably going to have to be the way that I'm going to go. This will be some good practice. So let's build a nice big let statement. So let, as first steps, we're going to have one step in this one. What I want to do with this is I'm going to build a whole 3x3 map, get all the addresses, get all the values, use that to determine where to go, etc., etc. So, the width of that array. So when a step is 1, the width is going to be 2. When the step is 2, the width is going to be 5. So the width, I'm thinking, is steps times 2 plus 1. That sounds about right. All right, now let's get our row number. So row number is going to be, this is where I'm going to use this make array function. The make array, so it's going to be following that width in the function. So with the make array, we can use the lambda with R and C for row and column. Now I want this one to show me the respective row numbers. So it's going to be R here. So thinking mentally in my head, actually, let me just show you here. So when I just use R for row, what it's going to do is it's going to return row number 1, row number 2, row number 3. When I get a 5x5 array, it's going to be 1, 2, 3, 4, 5. Now, in this one, I want row 1 to turn into -1, so that's going to be 2. In my 5x5, I want 1 to turn into -2, so that's going to be -3. So -2, -2. So is that just going to be row? The row number is just going to be the number of steps. Wait, the row number has to be subtracted by double the number of steps. So row minus s times 2. There we go. All right, and let me just check with the larger array. No. Oh, it's not s plus 2. It's or not s times 2. It's s plus 1. That needs to go in parentheses now. There we go. So 2, 1, 0. There we go. Okay, good. So that gets us the row number. Let's do the same for the column number. So this is column number. So it's going to give us, whoops, nope, that's still RNC. This R needs to change because that's a column number that needs to change. Right. And then addresses is going to be row number, column number 4. Let's see how that turns out. Oh. Oh, okay, yeah. Okay, yeah, because I need to adjust with that. So, row number is going to be that make array. So that R minus S plus 1 plus so we need to add the row number in there, and then we need to add the column number in here. So there we go. Now when I do my addresses, right, so U2 is in the middle here, which is what I want. Let me try this with this. U2 is in the middle. Ah, okay. We're getting some errors now. And this is what I expect. So I was thinking originally of an offset error, but the problem with offset is if just one cell goes off of the sheet, then the entire return is going to be an error. Whereas when I'm doing it this way, see, when one cell goes off the sheet, only that cell, or only that row, in fact, is going to be an error. And so that is perfectly fine. That gives me all of these other cells that I can work with, which is exactly what I want. All right, so now that I got that, let's go ahead and take this back to 1 for one step. And then let's get the values. So we're going to XLOOKUP the addresses and from this column, and then return from the value column. And let's just lock these just in case. I don't know if I need to lock them, but I'm going to lock them. Right, and then let me just see what vowels looks like. I'm not defining the same name twice, am I? Am I? Oh, forgot to take that out. Right, okay, there we go. So we have values. Right, and so let's do if error. If these do not come up with an error, we're going to give it a value of 0. Which is fine because we're not going to worry about it. Excellent. So we have all of the values of all the cells around us. Let's do the same thing with two-step. Excellent. Good. Okay. Now the next thing is we have a certain priority order, right? And the priority is going to be in this order. Now, what I'm going to do with this, I'm going to do a little bit of a, let's do priority. Let's do sequence. With the row and width, start with the largest number and decrease. Now, that's going to give me the same as what I've got up here. Yes, there's an 8 here instead of the 9 here. That's fine because it's still in the right order. The key thing is the order here. Now, while I'm thinking of this, the one thing I'm just realizing is I need to not count any cell that's already been visited. Because if the cell's already visited, that mineral is going to be gone. So let me just spread this out. Let's make this as target, let's say. Now, we can put U2 here. I wouldn't like to because I'd be worried that there's a mineral there, but we visited it where actually it's blank, and so that's going to work. So let me take the values here. So the values is there times so if the ads ever shows up in a previous move is equal to 0, then 0, otherwise 1. So what that does is that multiplying it, if it shows up before, it's going to multiply it by 0, turning the value into 0. There's no more value in that cell because there's no more mineral in that cell. Right, and then we've got the priority list here. Let me just check, does a priority list work with a larger array? Yes, it does. So it goes from 1 to 25 there. Excellent. All right, so next step that I need to do with this is I need to find out the largest value, return the address, but also consider the priority. All right, so I'm going to make 2 more variables here. I'm going to do sorted vals. What this is going to be is I can only sort them when they're in a column. Oh no, I need to sort by because I'm going to sort by the priority. Sort by 2 call priority. Now, I don't need to check these because I know that when they're in the 3x3 array, they're in the same spot. And so when they convert to a column, they're going to be in the same spot. And we're going to sort that by 1. Yes, because 1 was in the bottom right corner, right. So we need to sort that by 1. So that's going to stew my sorted vals. And let's just check. So if I remember right, 35 should be on top because 35 was in that one cell there. Yes, okay, good. Now we're going to do sorted adds. I can spell. I'm going to do the same thing. So sort by 2 call adds by 2 call priority in the order of 1. So now let's do this. Let's do hstack sorted adds with sorted vals. Let's see how that looks. Good. All right, so V3 is on top. That has a value of 35. And that is where I want to go to. Now, sometimes that largest value won't be on top. So, final thing is we're getting to the output now. So let's do output now. XLOOKUP max vals in... Okay, that works. We can do max vals here, but when we do the XLOOKUP, that has to be in the column. So we're going to look it up. And sorted vals return sorted adds. If not found, I don't think it should be not found, but in case we'll put 0. And let's see what output comes up. It comes with V3. Excellent. Now, one thing that I do want to add is what if they're all 0? Because that's when we know we got to move to the next step, right? So, if max of vals is 0, then just return 0. Otherwise, return all of that. Okay. That was a nice, pretty, long, single cell formula. Let's go ahead and... so this is now going to be here. Actually, you know what? Let me just prepare. Trim range, this range. And so what that's going to do is that's going to turn all 5 into 1. And then let's go ahead and take -1 column. So if it's 2-step, it's going to take that second column and so on and so on and so on. Okay. Ooh, that did not work. Oh, that shouldn't. Oh, this should be here. And then the rest can fill down. It still did not work. Oh, because that's got to fill down as well. There we go. Okay, so we got our target. Let's get our value. So we're going to XLOOKUP that into our mine, return the value. And what's the total? The total is 360. Excellent. Okay, that all lines up. That all matches. That makes Ben happy. Now, the hard part. We need to consider all of these days. And of course, they have different numbers of turns. So, what we need to do is... So, the example is going to respawn. So, we're going to overwrite our example in this table there. But what I want to do... Alright, so let's get all of our day numbers in. So, let's do let's get all the day numbers in sequence in a row. So we're going to do 10 rows starting with the day number and not increasing. So that should be 10 ones. That should give me the rest of all of my numbers. So we've got 10 ones, we got 15 11s, yes, 13 13s. Okay, cool. Now when I go here, because it's all connected, so I can't do a data table like I mentioned before. So I need to throw all of the days, all of the trips in the same table at once. So I'll bring all of those together, removing any blanks. Excellent. So I have 276 moves, 276 there. Okay, we're good. Okay, so that's getting all the days in. Now for the turn, we're going to count how many times the number turns up every time the number turns up. Okay, so 20, let's just check. Okay, so that's going to 10, good. That 2 is going to 10. I think I saw 20 went to 24, which is what I want. All right, excellent. All right, now the start. Okay, so the start's going to change. And in fact, we don't need to reference that cell anymore. We should probably reference this cell now. So if this is 1, then we need to reference it from this sheet over here. All right, so that is, so if it is the first turn, yep, we need to find the day number. Oh, is that not going to work? That should work. Be 54 pound. Yes, it does work. Okay. Look it up in case GG, return from case HH. Otherwise, leave it blank to find out what to do later. Yes, we get a spill error. That's fine. Oh, 2. That shouldn't be 2. That should be a cell reference. Oh, I can't. Okay. I bet you what it. Yeah, so this gives me a cell reference. This doesn't. I bet you there's a 1 up there somewhere else. So let me change these references to only within that level. Does that work? Oh, I need to do all of that. There we go. Okay, so we got U2 when it starts. Excellent, 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 excellent. Right, so if that's not the case, then just give me the target from the last step. Okay, that's not what I want. All right, then let's do this. Oh, I know why. Let's take this away from ranges and just do single cell. Okay, there we go, there we go, there we go, there we go. Good, good, good. Okay, and then I'm going to copy this and paste it all the way down. And I see, okay, I'm seeing zeros. Where's my values? Oh, okay. Well, let's just turn that into a single cell as well then. I'm getting a bunch of zeros. That should not be a zero. Oh, yeah, yeah, okay, okay, yeah, yeah. I'm getting a bunch of zeros, so like from here, there is nothing around it. So that's where I need to go to my second step. So this is going to tell me when I need, if I need to continue to the second step, which 100 and, okay. So let's, do I want to lock things? Let's lock things. I think I just need to lock this. Because I think everything else, oh wait, no, I need to lock this. I think everything else is properly locked. Looks like it. So if I move this over to here now, so this is going to be step 2, but this is going to be different. So this is only need to be considered when this is equal to 0. If that's equal to 0, bring all of that out. Otherwise, just give me that previous cell. Oops, that's not the previous cell. This is the previous cell. This should be E as well. Yeah, that makes sense. Okay. So let's see when I consider the 2 steps. All right, we got a lot of 2 steps in there. That's good, that's good, that's good. So how many zeros are in the 2-step column? 24. Okay. Let's do the same thing for 3-step now. And 3-step, I shouldn't have to lock anything, because I'm already locked, and that final formula should then also flow along with it. So 3-step, how many zeros do I have? Oh, I'm down to 0 zeros, which then means everything should have found a destination. Awesome, awesome, awesome. Okay, so let's go ahead and get our total values here. So we have the 20 days. So let's go sequence 20 and then sum ifs. So we're going to sum that if that equals one of our days there. I scrolled too fast before Excel could actually do the math. Spill recess. Okay. Let's see if this all lines up. I'm really hoping it does. I'm not so confident. It does. Excellent. That's a lot of data table, so I don't need to go back and delete it, but I still have about 10 minutes to do the bonuses. We've already done bonus B. Let's do bonus A. Which card is dealt the most frequently to any of the players across games numbers 1 to 20? Okay, excellent. So this is where group by is my best friend. So let's cards B. We got to put this in columns. The group by only works with things in a single column. So I'm going to put all of those cards into a single column. And then we're going to group by cards. Oops. Cards again. So cards for the row headings, cards for the values. We're going to count how many cards we have. And then we're going to sort from largest to smallest. Yes, I need a second parentheses. I forgot to add that. Thank you, Excel. Ooh, that's going to take a long time. All right, so we got 8 of diamonds is the most. I'm going to use this at. This at tells Excel only bring up the very first value in the entire array. There we go. And let's paste that in there. Excellent. How many water cells are there in the maze? Oh, this one's going to be really easy because if you remember, the maze was section 3. So count if section 3 map was water because we renamed them, right? So that should give me the answer there. Excellent. Out of the 900 scarf color components on the S4 Scarves tab, there's a color component that is used the most. How many times? Hey, guess what? We could do the exact same thing that we just did. So let's colors B to call all of these scarf colors. Whoops. There we go. All of that in a single column. So group by colors, count A, -2 again. Yes, I forgot the second parentheses again because I'm too lazy and I don't type it myself. Which one is used the most? The W is used the most. So how many times? That's the add symbol is not going to work because we want this second cell here, not the first. So we're going to index first row, second column. That should give me the answer there. Let's go ahead and paste it into that cell. Very good. Finally, what is the total value of all the minerals in the mine? Oh, excellent. Since we have that column in this mine tab, we just need to sum that column together and we will get our value. And there we have it, folks. That is how you solve the morning session qualifier case for the Microsoft Excel World Championship 2025. I felt, as with most other competitors felt, these first 5 levels weren't too hard. I think I started with the scarf one because I thought that one was going to be the easiest. And I think, is there another level marked as easy? This World of Warcraft one was marked as easy as well. So I think I took that one on second, which is the beauty of this case because they're all unconnected. You can choose which order you want to take them in. And then this case was marked as very hard. And so just as you saw I did today, I took this one last. And I'll be very honest with you, it took me a while to try to figure out this solve. This make array function is one that I've not used before. But I'm really glad that I used it this time, and I'm really glad that I got to learn it because I feel that this will be something I could use in the future. Added note, I feel like a lot of pros and experts would use what they call a recursive lambda, which is basically a lambda that calls itself, that lets it go over again and again. I've not seen the other videos. I would imagine that people like Dim or Bo would probably try to take on that challenge. I'm thinking recursive because I'm thinking you start with one step. If they're all 0, you go to 2 steps. If they're all 0, you go to 3 steps, etc., etc., etc. I've never done that. I don't know how to do recursive lambdas, so that's why I did it in this column format, and I'm just glad it all worked out. So I hope you enjoyed this video. I hope to get the afternoon session out too. So in the Microsoft Excel World Championship, all the cases are done in 2 sessions, morning and afternoon. And the reason that it's done this way is so that all competitors get an opportunity to try out a case at a time that's convenient to them. For me, the afternoon session would have been run at midnight, so that was not convenient for me. But we do have the case. I do want to give it a go, and I do want to upload that video to this channel. If you want to see that video, make sure you subscribe, click the notification icon so you get notified when that video comes out. And as always, in the description, I'm going to link the case, I'm going to link the introduction video, and I'm going to link all the other competitors that have tried this so you can see multiple approaches and maybe just give it a shot on your own. Thank you so much for watching. Hope you enjoy this, and I'll see you for the next video.
It's the Excel World.